Hello and good evening. CTS265, Section 840 students for the Fall 2016 semester at Anne Arundel Community College. This is the CCNP route course, and this evening's video tutorial is going to be on Cisco Learning Labs Challenge number 8. So this was our challenge activity for the week here, wrapping up chapter number 5, and we talked about redistributing EIGRP into OSPF and OSPF into EIGRP. And so we're going to end up here with a two-way multi-point redistribution scenario. And again, this is another absolutely phenomenal activity here to really get us to stop and think about how we would approach things. So we've got the scenario here. You can see, what do we got here? Somebody configured something. Okay, so we just want to configure two-way multi-point redistribution. That's going to be very straightforward. And then here's what's going to be our challenge down here, right? This is going to be sort of the difficult part, or I should say the most challenging part, is we need to take advantage of the faster links when accessing network resources. So we need to make sure that our one prefixes, right, for 172.16.18 and 172.16.19 go only over the Ethernet links. And the reason that this is going to be a challenge is R1 and R4, and let me pull my job aids up here. This is going to be very similar to an activity, if not identical to an activity that we had done earlier, where you can see that we have basically router 1 and router 4 are going to be autonomous system boundary routers. So again, we've got this OSPF area 0 over here. So from the perspective of router 3, 1 and 4 will be ASBRs, because again, we're going to be redistributing information that is external to the OSPF domain area 0 over here. And then likewise, over here with IPv4 EIGRP Autonomous System 100, we're going to be redistributing on router 1 and 4, right? These are our border routers here, or I should say autonomous system boundary routers from the OSPF perspective, and they're border routers from the EIGRP perspective, because again, they're going to allow us to redistribute the OSPF network information into EIGRP. And so what we're going to have when we're finished is we're going to have OE2 routing information, and we'll say that this is the OSPF area 0 over here, and we're going to have OE2 information over here. That is the EIGRP information sent into OSPF, and then likewise right there, the OSPF information that shows up over here will be DEX, right? So D for dual, the diffusing update algorithm, and EX for external EIGRP. So we'll have an administrative distance of 170, and here we'll still have our administrative distance of 110. Remember, the administrative distance doesn't change. The metric, our seed metric, will be 20. And we'll see, maybe we can spice things up a bit and maybe change the metric when we redistribute in. So let's go ahead and clear our screen here, and let's dive in to this activity. And again, the majority of our work is going to be on routers 1 and 4. I'm pretty sure that 3 and 6, we're just going to be validating things from the perspective of 3 and 6. And so those two networks we mentioned, actually, let me make sure I point that out, they actually hang off of router 5 over here. So this is where we have our 172.16.18.0 and our 172.16.19.0. So they all hang off of router 5 here. And again, we want to avoid using that slow serial link. We want router 1 to come this way. But we're going to see why that's going to be difficult, because remember, these are going to be EIGRP internal routes with an administrative distance of 90. And router 1 and 4, they're both running OSPF over here, and again, EIGRP here. So when I redistribute that information from 4 into here, it's going to come as an OE2. So 1's going to see it, but it's going to see it with an administrative distance of 110, as opposed to the natural EIGRP, which is going to have an administrative distance of 90. I apologize. An administrative distance of 90. All right, so let's go ahead and clear the screen here, and we are going to jump onto the command line. All right, so let's pull up router 1. Let's also pull up router 4. And we're going to go from user exec into privilege exec, and we'll say show IP route. Oops, sorry. Show IP route. So there's the information that we have so far on router 1. You can see we have some EIGRP information. I believe that is the transit segment, or it may be a loopback from somewhere. And then we have our EIGRP learned information. Again, the last two bottom entries here, remember, those are the two entries we're going to be dealing with here in a second. And if I were to say trace to 172.16.18. Well, say 18.1, you'll see that we're going to go via this successor next hop router, right? 172.16.10.2. That is going to be router, I think it's 2. Yeah, that'll be router 2. That's the interface right here on router 2. And that is actually mislabeled right there. You see how it says Ethernet 2.0? That is not Ethernet 2.0. If I say show IP interface brief, you'll see that Ethernet 2.0 is unassigned administratively down. It's serial 2.0. So just a minor typo there, but that is our 172.16.10.2. And you can see that is the direction we go. We go to 10.2 over the serial link, and that's router 2. Then we go to router 6, and then to router 5. And then we reach that 172.16.18, right? But we're going via router 2. So if we go back to the drawing, sorry, or actually back to router 1 here, let's go ahead and take a look at the show IP protocols output, show IP protocols, and we can see what we have running here. And it shows us EIGRP AS100, and then we should see OSPF process ID 10. Now remember, when we redistribute from OSPF into EIGRP or EIGRP into OSPF, all of the routing information that's going to get redistributed is basically having its attributes and characteristics stripped away, right? So these EIGRP routes, when we redistribute them into OSPF, they now become OSPF routes. And so all of those EIGRP traits and characteristics, that composite metric, the bandwidth, the delay, the metric itself, right? It all kind of disappears, right? It's stripped away from the routes as they're injected and redistributed into the receiving routing protocol. So let's go ahead and get this two-way multi-point redistribution sorted out here. So the first thing that we're going to do is on router 1, we're going to go ahead and set up a prefix list because we want to match the information that we're going to be interested in here. So we're going to say IP prefix list, and we're just going to call it OSPF_nets, right, for OSPF networks. Because when we do the redistribution, we're going to apply a route map, and that route map is going to be calling this prefix list. So OSPF nets, we're going to say permit, and what are we doing here? So this is going to be the OSPF networks. We're going to redistribute 10.10.0.0/16 less than or equal to a /24, right? So we're going to get everything from a 172.16, I'm sorry, everything from a 10.10.0.0/16 up to and including a /24. So it's a pretty wide range of networks that we're going to be looking at. And so that is, sorry about that, I can put a little slash in there. So that is what we're going to be matching with our prefix list. So now let's create the route map that's going to call this prefix list. So I say route map into _EIGRP permit 10. Now I don't need to put the permit 10 actually. Remember, that's the default, so that's what it will take it as. So I'm going to say match IP address prefix list. And remember, the prefix list that we're matching is the one that we just created, OSPF_nets. Now, this is redistributing OSPF networks. We're going to be redistributing these into EIGRP. Now, I can do this on the command line, right? Or in the EIGRP global config section, but it's easier for me to do it here with a route map because I can simply say set the metric, and we'll just set it to 1500. Oops, sorry, 1500 dot. What are we going to do here? We'll say 10, 255, and then 5 and 1500. So we'll use 1500, 10, 255, 5, and 1500. So there is our route map, and there is our prefix list. So how are we going to apply this? Well, let's get into router EIGRP 100. And remember, before I do this, if we come to router 3 over here, what is router 3 seeing right now? So show IP route. So that's it. Router 3 sees nothing. Router 3 is not receiving any OSPF routing information, and it's not receiving any EIGRP information, right? Or redistributed EIGRP information, I should say. And now if we come over to router 6, we're going to see much of the same thing. So we're simply going to say show IP route. And router 6 has some EIGRP information. You see those D for dual, these internal EIGRP routes with a prefix, administrative distance of 90. And we see the 172.16.10, and we see the 172.16.18, right? And the 19 is locally connected here to router 6. So now what we're doing is we are redistributing that routing information here. And again, if I'm on this router and say do show IP route EIGRP, there's my EIGRP routing information, right? What about my OSPF? Do show IP OSPF. Oops, sorry, do show IP route OSPF. And so there's the prefix that I'm going to be redistributing in, is the 101013. So in the EIGRP configuration section, I would say redistribute from OSPF process ID 10, and I'm going to apply the route map. Remember, very, very similar to the activity that we did, excuse me, the activity that we did when we did one of the discovery activities, right? We redistributed OSPF with the process ID of 10 into EIGRP, and we applied a route map. And what did that route map do? It basically just set the composite metric values that EIGRP is going to use in order to calculate or assign an EIGRP composite metric to this redistributed information. Because remember, when OSPF information is redistributed in, if I don't assign the metrics, what is the metric value? Exactly. The metric value would be infinity. And therefore, this routing information, this redistributed OSPF information, won't show up in EIGRP. So all we've done here is we've kind of streamlined things. We created a prefix list. That prefix list is matching the 10.10.00/16 all the way up to a /24. And now we've called that prefix list via a route map. And if the prefixes match the prefix list, they're going to have their metrics set when redistributed into EIGRP from OSPF process ID 10 to what we had defined in that route map, which was, I think, 1500, what was it, 10, 255, 5, 1500. So we hit enter. So on router 1 now, we have just redistributed OSPF into EIGRP. So now let's come over to router 6 in the EIGRP domain, and let's say show IP route, and take a look at our newcomers here. And we also got that directly connected OSPF segment. So we now have two DEX, right? So EIGRP external prefixes because they've been redistributed into EIGRP, and there's my administrative distance of 170 to identify external EIGRP information as opposed to internal EIGRP information. So now let's go ahead and we're going to do the same thing. Basically on router 4, it's almost identical because remember, it's two-way multi-point redistribution. And this is also one of the most dangerous redistribution schemes because we are a little more exposed in terms of possibly creating a routing loop. So let's get into global config, and we're going to say IP prefix list. We'll call it the same thing, OSPF_nets. We're going to say permit, and we're going to permit on 10.10.0.0/16 on router 4 the same, less than or equal to 24. So again, we're still scoping down what we're going to be redistributing from OSPF into EIGRP, but remember, we're doing it on router 4 as well. Because if router 1 crashes, right, if we come back, and so you might be asking yourself, well, why would I do this? Why would we do multi-point redistribution? Because what if router 1 crashes? Then what happens? If we don't do the two-way multi-point redistribution here, as soon as router 1 goes down, all of these routers over here in the EIGRP domain, router 5, router 6, and router 2, they now no longer have those DEX, those external EIGRP routes that get them over here to router 3. And vice versa. If we didn't do it on router 1, but we did it on 4 and 4 dies, it's the same thing, right? 1, 2, 6, and 5 no longer have those DEX routes that have been redistributed. And so that is one of the reasons why you'll do mutual redistribution in a scenario like this. So back on router 4. So we've got our prefix list. Now we're going to go ahead and do our route map. So we're going to say route map, and we'll call it into EIGRP. Again, we're just redistributing from OSPF into EIGRP. We don't have to say permit 10, but I did there. So what are we trying to match? IP address prefix list. Make sure you put prefix list if you're using a prefix list. OSPF nets. Let's make sure that's right. Yeah, OSPF nets. And what are we going to do when we match anything in the 10.10.00/16? Well, we're going to set the metric, right? This EIGRP metric that's going to be assigned to these OSPF routes, and we'll just go ahead with and what do we do before? Did I say 1500? What? 10, 255, 5, 1500. And again, it's kind of arbitrary, the values that you assign. All right, so we're going to exit out there. Let's get into router EIGRP 100. So do show run section EIGRP. We'll take a look here. And there we go. Right now, we just have redistribute EIGRP 100. But we need to sort this out, right? We need to say redistribute OSPF. So redistribute from OSPF process ID 10. And we're going to control that or filter that redistributed information via our route map into EIGRP. And we already know what that does. So now let's come back out here to router 6, and let's see if router 6 sees anything different, right? Not really, right? It still sees the same information. We're doing that two-way redistribution using the route map. What about router 3? Do you think 3 sees anything different? Because we haven't redistributed OSPF yet, so take a look there, right? Nothing exciting on router 3 yet. So we've done the redistribution from OSPF into EIGRP. Now we need to do the exact same thing in the opposite direction, and this time we'll start on router 4. So now I need to redistribute from EIGRP into OSPF. And remember, my EIGRP networks are those 172.16s. So we're going to go ahead and say IP prefix list, and we'll call this EIGRP nets. Whoops, nets, and we'll say permit 172.16.0.0/16 all the way up to less than or equal to /24. Now let's get a route map teed up here. So we'll say route map, and we'll call this into _ OSPF, right? Just like we called the other route map into EIGRP. This is redistributing into OSPF. Permit 10 is implied, right? So match IP address prefix list, into _ EIGRP, and I'm sorry, that's our route map name. We want OSPF nets as, let me make sure I'm doing this right, prefix list, EIGRP nets, I apologize. I was looking too far up. EIGRP _ nets, and that is it. So if we match anything there, what are we going to do? Well, remember, with OSPF, we're redistributing from EIGRP into OSPF. And so there is no quote-unquote composite metric in OSPF. There is a metric, but it's not based off of the values or the formula that the EIGRP composite metric is calculated with. So we need to make sure that we also include the subnets, because automagically, what is the seed metric? Because EIGRP is not going to carry its metric into OSPF. OSPF is going to seed the EIGRP routing information upon receipt by the OSPF process with a metric of what? 20, right, because that is the default seed metric for routing information coming in from EIGRP, just like the default seed metric from for OSPF information going into EIGRP is infinity, right? Okay, so we say match IP address prefix list EIGRP nets, and when we do that, sorry, now we need to get into the router OSPF process ID 10. So we're going to say redistribute from EIGRP process ID 100. And I don't need to put the metric, I need the subnets keyword. And then we're using that route map called EIGRP, or I'm sorry, into underscore OSPF. Right? So redistribute EIGRP 100 subnets. And why do we need the subnets keyword? Exactly. We need that subnets keyword because without the subnets keyword, I would only get classful networks redistributed that matched that network statement. So in other words, I would get the 172.16.0.0/16, right? Even though my prefix list is set up here to say from a /16 to a /24 inclusive, if I leave the subnets keyword off, that route map the prefix list statement that's tied to the route map is sort of irrelevant because without the subnets keyword, OSPF is going to say, well, you didn't put subnets, so I can only bring in the Class B network 172.16.0.0/16. That is it. So we get that subnets keyword in there. Oops, sorry. And we hit enter. All right. And so a little easier, because we didn't have to set the metric, right? So we save ourselves a line of configuration on both ends. And so here's what we're going to do now. We're going to come over to router 1, and we're going to say IP prefix list, and this is going to be EIGRP nets, EIGRP underscore nets, and we're going to permit 172.16.0.0/16. Again, we're going to run it all the way up to less than or equal to a /24. But now we need to create the route map. So we say route map, and this is going to be into underscore OSPF. The permit 10 is implied. So at this point, we're going to match IP address prefix list, and the prefix list was EIGRP underscore nets. And when we match it, that's it, right? We're just doing a match statement. And actually, what we could do here, let's set something else. Let's set a tag on this, and we'll see this with the show IP OSPF database. So we're going to set a tag on this routing information, and it's not a bad idea, 8675309. And it's not a bad idea to tag all redistributed information between protocols, because the tag doesn't hurt anything, and you could certainly use the tag at a later time if you needed to. And so let me make sure, let's go back to router 4 here and get into the route map into underscore OSPF, and it was the permit 10, and we're going to do a set tag to 8675309. So do show route map. Okay, so there's our route map, and there are the set clauses. Do show run section route map, and let's make sure. And we've got it. Yeah, there we go. Match IP address prefix list EIGRP networks. And we're going to tag those EIGRP networks upon redistribution into OSPF with a tag 8675309. Right? For no other reason than it's going to allow me, when I do that show IP OSPF database and I look at those type 5 LSAs, because that's how we're going to see these EIGRP routes once they're redistributed into OSPF. When I look at the IP OSPF database, that is where I'm going to see the tag. So it allows me to easily look at that information and say, oh, that's right, we always tag EIGRP when we redistribute it into another protocol with 8675309. So then I'll know those are actually, they were originally EIGRP routes. And so let's go take a look at that after we get our router OSPF 10, redistribute EIGRP process ID 100, subnets, right? Very important, and we get that subnets keyword in there. And then route map is going to be into, what do we call it? Into underscore OSPF. All right. So now we've taken care of the redistribution portion of this exercise. We've got our two-way multi-point redistribution being run. Now, let's come over to router 6. Let's see what router 6 sees now. Again, still just those two routes, right? Because we've done the OSPF into EIGRP. Router 3 is going to give me a look. Yeah, there we go. So router 3 gives me a look at now, what am I receiving over here that's an OE2? All of those 172.16.0.0/16 all the way up to /24s. So I'm seeing the 172.16.10, the 11, the 18, and the 19. And you'll notice that from router 3's perspective, we've got equal cost paths, right? So we can load balance across these two paths. I can go toward, as router 3, I can go toward router 4, or I can go toward router 1, because I'm seeing them as equal cost paths. They've got the same metric. The metric is 20, right? Because they've been redistributed into OSPF from EIGRP. So now let's do a show IP OSPF database, and we'll take a look at what I was mentioning earlier. So check that out, right? And again, let's get back over to router 3 here. And again, it doesn't hurt anything. There's nothing wrong with tagging it. Even if we never use the tag for anything, if I look at this, and if this is a standard here for my enterprise, I can say, oh yeah, that means that these were originally from EIGRP, as opposed to maybe we're redistributing some routes in from OSPF, or maybe we're redistributing some routes in from static, or from connected, or from RIP, or ISIS, or whatever the case may be. You know, if this is my standard, I can quickly look at that and say, oh yeah, 8675309. Those were originally EIGRP routes. That's how that information got in here. And again, type 5 AS external link states, right? Because when they're redistributed in from EIGRP into OSPF, we're going to be picking these up as type 5s, as OE2s in the routing table. All right, so now down to the really challenging part here. And this really causes us to think about how are we going to do this. So remember, it's asking, or it's basically telling us that if I say show IP route right now, for the 172.16.18 and 172.16.19, you can see those two networks right there. What direction, or what is the next hop that router 1 is going to take? Is it going to go left, according to the diagram, over to router 3, or is it going to go right, according to the diagram, over to router 2? Well, when we see this, we can clearly see that it's going to go to router 2. 172.16.10.2 is the VIA, right? That is my successor next hop router. So we've been asked to change this and to make sure that it doesn't go to the right, it doesn't go to router 2 via EIGRP, that it goes to the left and it goes to router 3. So let's see, where does router 3 want to go? Show IP route. So router 3 has two equal cost paths here, right? What about router 4? Router 4 is directly connected to the 18, right? And you can see here that it has a route to the 19 that says go to 18.2, which means we're going to go this way, right over here to router 5, because it's simply a single hop away. But the key thing to notice is that both router 1 and router 4 are making their decision because they're selecting the EIGRP route. Now remember, these have been redistributed into OSPF. And so in OSPF, take a look here, let's bring this up a little higher, they are OE2s with an administrative distance of 110. Now here is where we walk through the selection criteria. The number one selection criteria for a router selecting a route, it's going to be the longest match first. So when the scenario presents itself that there are two equal cost paths, or there are two routes that have been learned from maybe different routing protocols, the number one criteria is, and they're the same route that you've learned, right? So you've learned the route from OSPF, you learned it from RIP, and you learned it from EIGRP. If all three of those routing protocol sources are presenting you with the same prefix and prefix length, right, or subnet and subnet mask, and we know that these are, I believe those are /24s, if they're all the same, then the longest match is a tie. Then we go to administrative distance. So remember, the number one selection criteria is always longest match for the subnet length. So we'll say subnet length. That's the number one selection criteria. The number two selection criteria now becomes administrative distance. And so there's a couple ways we can go about this. We're going to follow sort of what the reading and the discovery activity had us do. And now we're going to manipulate on router 1, because remember, it's router 1 that needs to make this decision. In router 1, we're going to change the EIGRP distance. But we're only going to do it for information for EIGRP routes that we're learning from router 2. So remember, what do we want to match? What are the two networks that we're talking about matching here? So we're going to say IP prefix list permit 172.16, oops, sorry, 16.18.0, 0.0, or actually, we'll do an ACL here. So we'll say, yeah, so we'll have to do an access list because we're going to call this. So access list 1 permit, and permit here means match. So 172.16.18.0, 0.0.0.255. And then access list 1, which means, no, access list 1 permit, which means we're going to match the 172.16.18 and the 172.16.19, both /24s. So that's what this access list is going to be used for, and here's where we apply it. So if I go into router EIGRP, at Autonomous System 100, and we say, I'm sorry, not redistribute, distance, right? So I want to tweak the distance. Now, take a look here. Set route administrative distance. Or we could set it for all internal and external information. Now, the problem with setting it for all internal and external information is that we've been tasked to do this only for the .18 and the .19, which is why we've created the access list, which is why we're only matching on those routes, which is why, now the administrative distance for OSPF is what? It's 110, right? Which is why those EIGRP routes are more preferred, because their administrative distance is 90. So if I set this to 111, that is going to be enough to change the way router 1 is looking at the two routing protocol sources of information. Now router 1, based on all information that it's learning from 172.16. Was it 10? 10.2? 10.2, 0.0.0.0, and access list 1. So distance 111, and here's what this says in English, right? Because I know sometimes this gets a little convoluted. So what we're saying here is set the administrative distance to 111 on all NLRI, or all EIGRP learned information from router 2, and that just basically specifically matches that exact IP that conforms, or that we match with our ACL 1. And what do we match with ACL 1? 172.16.18, 172.16.19. And so that is what this command allows me to do. It allows me a little more specificity, a little more granularity and control over which EIGRP learned information and from whom am I going to manipulate the administrative distance. And in the scenario that we're looking at here, that we have in the diagram, this is going to work, because it's not like router 1 has another connection here or a serial link here, right? Those don't exist. Those links don't exist. We're simply saying that from router 0, for the 18 and the 19, I don't want to go that way. I want to go this way. And to go this way, I need the OSPF learned routing information that is going to take me this direction. So I need that OSPF information in the rib on router 1. Well, we've got two sources of routing information, OSPF and EIGRP, and the information that they're both sending into router 1, the prefix and prefix lengths are a match. So then we come down to administrative distance, where EIGRP is my winner. But we are manipulating that right now. We're going to change that, but only for the prefix information, 172.16.18 and 19, and only when learned from router 2. We're going to apply that ACL. So let's go ahead and hit enter. And I believe this is going to do a reset. It's not I don't believe it's graceful. This should be a hard tear the adjacency down, then bring the adjacency back up. It's going to be a hard reset. Yeah, so there we go. The adjacency went down, the adjacency came back up. And so this is something that you probably want to have worked out before you start tinkering with this in the middle of the production day. Because as you can see, the adjacency went down. It came back up right away, but it went down. So here's what the routing table looked like before for the 172.16.18 and 19. Now let's take a look at what that information is going to look like, or what this rib is going to look like once we made our change. So do show IP route. And now take a look from router 1's perspective as to what protocol is now installing these routes in the rib. Is it EIGRP anymore or not? No, it's not. It's OSPF, and it's OSPF because the administrative distance is 110. So I could have set the administrative distance, as long as it's something greater than 110, we're good. But I want to make sure, remember, we're talking about EIGRP here, so I also want to make sure that it's less than 170, because 170 is the default administrative distance for external EIGRP information. So again, we set it to 111, and that was more than enough. You could set it to like 150, might be a better selection, right? If we're trying to get away from 110 a little bit, make sure that when you look at it, you're like, oh, okay, wow, I see that the administrative distance is 150. That's clearly greater than 110. Instead of 111, you may look at that and be like, well, wait a second. So I used 111 to show you that it just needs to be 1 greater than for the comparison by iOS to look at that and say, yeah, no, this is OSPF, right? Because the administrative distance is less than the administrative distance that was just assigned to those two prefixes. So again, we set the administrative distance using the distance command and an ACL for information learned from a neighbor. All right. So that is going to wrap up this activity, challenge number 8. Again, another fantastic Learning Labs challenge here that really sort of had us pause and think, how are we going to approach this? How would this get done? All right, thanks so much for watching, and I will see you guys tomorrow night.